Let's learn in this Lightboard session how to configure a private DNS zone with a private AKS cluster. For that, we'll explore the options for configuring DNS with a private AKS cluster during the creation. So typically you would have two options, which are two feature flags that you can enable or disable when creating your AKS cluster. First of all is disable public FQDN. So this value could be either true or false. We'll see what is the impact of using this feature. And then we have a second option that is called Private DNS Zone. Private DNS Zone takes three options. First option is none. It means that here I don't want to use a private DNS zone, or system. It means that the private DNS zone will be created and managed by the AKS cluster, or it could also be the resource ID. And this is the use case for using bring your own private DNS zone that you manage yourself. Let's take this first use case where here we have an AKS cluster that is attached to a customer virtual network using Private Endpoint. A private DNS zone will be used to resolve access to the control plane of the cluster. Here, because we have one single virtual network, then any VM or any workload within that virtual network will be able to resolve access to that control plane. This is the typical configuration where we use disable public FQDN to be true, and at the same time private DNS zone will be either equal to system or it will use bring your own DNS zone. In both cases the AKS cluster will create the A record. But now for organizations that are using hub and spoke models, they will have the AKS cluster attached to the spoke virtual network, and then they would have a hub that is peering with that spoke, and the hub itself might be also peering with other spokes, and it might be also peering with on-premise virtual networks. And here we want to be able to resolve access to the AKS cluster from any workload or VM from within the spoke virtual network, and also from any VM that is within the hub virtual network. So again, here we can rely on the private DNS zone to achieve that domain name resolution, but actually there is a more easy solution. The solution is to enable the public FQDN. So this means that here when creating the cluster, we'll set up the disable public FQDN to be false. And then we don't need to create a private DNS zone. So we'll set private DNS zone to be equal none. So this means here will not create this private DNS zone. It won't be created. And by setting public FQDN to be equal false, this means that here the FQDN of the control plane of the cluster will be resolved not through that private DNS zone because it's not created, but it will be resolved through Azure DNS. So this means that here within Azure DNS, we will have a record that is the FQDN of our cluster that will point to the private IP of our cluster. And this FQDN will be resolvable publicly from the internet. This means that also our virtual networks, including the hub and the spoke, will be able to resolve that FQDN publicly to get that private IP to access the control plane of the cluster. Now, the fact that this FQDN can resolve the private endpoint private IP address publicly on the internet, this could be acceptable by some organizations because they will consider that the AKS control plane is still secure because you have airbag access control, and the only way to access that control plane is from within the virtual network. If you belong to those people, then this architecture would be the simplest for you to implement. However, for some other companies that will consider that public FQDN is a security threat and they don't accept that will resolve to a private IP address because they consider that if an attacker within the virtual network knows that private IP address, that will be considered as a threat to the control plane. So for these people, we have other options to consider. So they will need to use the private DNS zone. This means that they will have their AKS cluster control plane exposed through a public or private endpoint that will live within a virtual network that is the spoke virtual network that will be paired with a hub virtual network. So here they will go to disable that public FQDN. It will be disabled by setting disable public FQDN to true. This means that they should use or they should rely on a private DNS zone that they will set up right here. And to create that private DNS zone, they have two options: system or resource ID, or bring your own DNS zone. So with system, it means that they will allow Azure or AKS to create that private DNS zone and manage that private DNS zone by creating the A records. With resource ID, or if you use bring your own DNS zone, this means that it's up to you to create the private DNS zone before creating the cluster, and then when you create the cluster, you specify private DNS zone to the resource ID of the private DNS zone, and in this case, the AKS, through its identity, whether that is managed identity or service principal, it will go ahead to connect to that private DNS zone, and it will go to create an A record. And here this private DNS zone will be, of course, linked to the hub virtual network. This means that any virtual machine inside here will be able to resolve that private endpoint. In addition to that, actually, a new link should be created here from the spoke to the private DNS zone. This might change in the future, but today this is needed for the AKS to function correctly. And this link will be used by the nodes of the cluster that are within the spoke VNet to be able to resolve the IP address of the cluster. Now, if we have multiple AKS clusters with multiple virtual networks, we can still use private DNS zone, but we can leverage also the subdomain name through creating a child private DNS zone. A child private DNS zone is actually a private DNS zone that will use the same prefix for the FQDN that is used by the DNS zone, and it will be attached to this parent DNS zone. So this model could be used and leveraged by the additional DNS or the additional virtual networks and the AKS clusters in order to, instead accessing the private DNS zone and creating A records there, they can do that at this level, at the child DNS zone. That could be leveraged by using another flag when creating the AKS cluster, that is the FQDN subdomain. Let's now analyze these solutions in terms of operating model. So for the first model here, this will be typically used by the application team who will own their own infrastructure. So they will own their own AKS cluster, their VNet, and their private DNS zone. So they can write records within that DNS zone, and that should be feasible. Second use case here, this part here is owned by the application team or the project team, and this part here will be owned by platform team. The project team will typically create its own resources for within their own spoke virtual network, and also the project team or the platform team, they will create the hub network with the DNS components and so on. And here we don't have private DNS zone, so there is no interference between the responsibilities of the two teams. However, in this model, we have an issue here. So the AKS and the VNet will be owned here by the application team or by the project team, typically within most of the cases. However, this part here, that is the hub and the private DNS zones, will be owned by the operation or by the platform team. Sometimes we call them the ops team or the infra team or the security team or the network team, whatever you want to name it. It's another team. It's a different team than the project team. The issue here will be at the level of the private DNS zone. So the private DNS zone, if it's central private DNS zone, it means that we will create only one single private DNS zone attached to the hub virtual network that will be managed by the platform team. However, here, the AKS cluster, using its identity, needs to go to connect to that private DNS zone and create an A record. And the fact that it could create that A record, this means that the platform team will be afraid from that operation, because that identity of the cluster that have the right airbag role to do that change within the private DNS zone could be altered, and it could be used to add or delete or edit some existing A records for the other teams. So they don't want really to trust this operation. In this case, they have two options. First option is to just accept that risk, because this risk of using this identity is the same risk as using another identity that is managed by this platform team to do the same operations on the private DNS zone. The second option is to not allow the project team to do this operation, and instead they can do that either manually or using automation tools like the DevOps pipelines or automated scripts that will go to be triggered on the creation on each new AKS cluster, and the private endpoint that will go to look for the FQDN, and then that script will go to write the A record within the private DNS zone. The issue again with this is that FQDN should be created before creating the AKS cluster, and we don't know which FQDN will be used by the AKS cluster because part of that FQDN is a prefix that is randomly generated. So this will leave you with one single option, which is the first option, which is to accept that the identity of the cluster creates that A record. This might change in the future, so keep an eye on the AKS updates. I hope this was helpful. Thank you.